Now that we've looked at the main portion of the EX24 case study, it's time to turn our attention in part 2 of this case study to the example countdown timer class and the superclass that it extends. So example countdown timer is over here in the utils directory. See, it's this thing here. And this is basically a variant of the countdown timer class. This is something that's taken basically out of the Android source code release, pretty much what Android has. And I just took it and I wrapped it so I could parameterize the lock. The one that countdown timer uses has some different mechanisms, but we're going to parameterize it with the lock and also with the countdown lat. So let's take a look and see how this is going to work. So you can see here we have this example countdown timer. It calls up to the superclass, which is countdown timer, as you can see here, which is the one that's based on the Android implementation. And this particular implementation is going to have a bunch of fields. It's going to have something that keeps track of the milliseconds in the future when to stop all the countdowns. It's going to have the countdown interval. It's going to have something called a scheduled executor service, which is a really cool thread pool in Java. And we're going to make ourselves a thread that we set to be a daemon thread. You may recall a daemon thread will not prevent the program from exiting if there's only daemon threads left. We then keep track of when to stop the timer in the future. We keep track of whether we've been canceled or not. And then over here, you can see that we have a field called lock. And this is the parameter that's passed in. You can see how the countdown timer constructor is going to take the lock parameter that's passed to it, and it's going to stash it away in this field along with the milliseconds in the future and the countdown interval. It will then go ahead and get ourselves a scheduled executor service that we work on with the scheduled thread pool executor interface. And the reason we do this is so that we can set the policies on the thread pool executor to be sensible. Out of the box, they're not sensible, so weird things happen. So we have to set them to be something more sensible. We set the remove on cancel policy to true, which says when things shut down, we remove things. And we do a couple of other things to stop periodic tasks and delayed tasks after shutdown, which are for some reason set, in my view, incorrectly. So let's then see what happens here. So that's what the subclass example countdown timer has an extension of countdown timer. Countdown timer, as you'll see, has a couple of pure virtual methods or abstract methods that are defined by the example countdown timer. So let's take a look at what they do. There are two methods here that are overridden from the superclass, and we'll take a look at the superclass in a second. And those methods in example countdown timer are onTick, which is going to print something every period of time, in this case, every 1 second. And then there's also something called onFinish. onFinish is just going to say, I'm done. But onTick is going to do something interesting. When onTick is called, it prints how many seconds remain, and then it goes ahead and decides whether or not we should cancel the timer. And we do this by checking to see if we're roughly halfway done. So if we were going to be doing this for, say, 10 seconds, and then about halfway through, we're going to try to cancel ourselves. Take a look here. We make an innocent enough looking call to cancel, but we're about to find out that this is actually very dangerous if a non-reentrant lock is used to parameterize the example countdown timer. So keep your eye on that. We'll come back and look at that. This may deadlock if we don't have a reentrant lock. Assuming we have a reentrant lock, we then decrement the latch because we're done. So let's go now take a look at the countdown timer class. I kind of showed you what the implementation methods that override it do that are defined as abstract. So let's take a look here. First, let's just go take a look at the methods that are the abstract methods. We've got onTick and onFinish. You can see they're abstract. That makes an obligation on the subclass to override them, as we saw here. There's also a bunch of other methods here in countdown timer. And the first one we're going to take a look at is the start method. So what start does is when start is called, and we saw where start was called, that was called over here in the kind of the driver program. When that's called, we acquire the lock because we're about to muck around with shared mutable state. We're going to indicate that we haven't been canceled yet. We're going to check to see whether or not we're done. If we are, we call the onFinish hook method. So in that case, call hook method to indicate we're done. If we're not done, we then figure out when we want to stop, which is essentially, or the next time to stop, which is the current time in milliseconds plus the milliseconds in the future. And then we go ahead and schedule the initial timer. We'll look at that in a second. And then we return this object to support fluent interface chaining. And then, as always, we always unlock the lock in the finally portion of a try finally block. Okay, so far, so good, sort of. Here's scheduled timer. scheduled timer is going to make ourselves a new runnable using an anonymous inner class, which is kind of long. I could have split that off into its own class or its own nested class, but I chose not to. And because of the fact that we access the this reference, we have to make this an anonymous inner class. We can't make it a lambda expression because lambda expressions can't be used if you access this, because lambda expressions are not actually objects, which is kind of useful to know. So this runnable has a run hook method. When this run hook method gets called back, it's going to be called back because we're going to register this runnable with our scheduled executor service. We're going to schedule it to run this many milliseconds into the future, which starts out at 0. We're going to start this thing off by saying run this right away. Now, whenever it's time to run, its run hook method gets called back. And notice the first thing it does is it acquires the lock, because once again, it's going to muck around with shared mutable state. So we check to see if we've been canceled. We figure out how much time is left and so on and so forth. If we're done, then we go ahead and call the onFinish hook method. Otherwise, we call the onTick method. And onTick, as we saw over here, is what's overridden by the user to do some user-defined thing. So in this particular case, we don't really care what it does, but it turns out we actually do care, because you'll see here our onTick method turns around and calls back into the framework. And as we'll see, that causes chaos and insanity if a non-Reentrant lock is used. If a Reentrant lock is used, chaos and insanity is avoided. So then we go ahead and figure out sort of how long things took to run. We figure out whether or not we need to speed things up or slow things down or whatnot. There's a bunch of special cases. I won't really go through them. You can read the comments. And then what we do is we go ahead and we reschedule this timer handler. So that's the thing that we're creating. This timer handler is going to be rescheduled to run again at the appropriate point in the future, which is this delay variable. And you can see delay is what got set here based on how long the other onTick callback took to run. So there's a little clever math, time-based math here that does this. So we reschedule this thing to run in the future. Okay, still sort of so far so good. Now let's take a look at where things get dicey. So you'll notice that the onTick hook method calls this cancel. And if you go take a look at this cancel, you'll see what this cancel does is the first thing it does is it goes ahead and it calls lock, because it's about to muck around with shared state. And we need to make sure that when shared state is mucked around with, we have to ensure that it's going to be protected. That's a very important thing. So we call the lock. If we have a Reentrant lock, all is well. If we don't have a Reentrant lock, this will self-deadlock and will end up being stuck here until the main thread ends up timing out, as you can see over here. But if it doesn't, until it times out, we're stuck in self-deadlock. Assuming we're not stuck in self-deadlock because we used a Reentrant lock, we update mCanceled to be true, saying we have been canceled. We shut down the scheduled executor service because we don't need it anymore. That cleans everything up. And then we unlock ourselves on the way out. So that finishes our walkthrough of the CountDownTimer class and the example CountDownTimer class that extends CountDownTimer. And now it's time to turn our attention in part 3 of the lesson coming up to the implementation of the non-Reentrant spin lock class.